To find AB, we have to subtract OA from OB.
So we have
1 minus 2 and 2, and this is AB. Part B states that ABCD is a rectangle and that AD is equal to 4, P, and 1. The question asks us to show that P is equal to 3. So let's draw the rectangle.
A, B, C, D.
We know the coordinates of A and B,
And this is 6, 0, 3, 5, 2, 1.
and we also know that the difference between A and D is equal to 4, P, and 1. So we know that to find D, we need to add these values to A. So D is equal to
We know A, 5, 2, 1, plus 4, P, and 1.
9, 2 plus P, and 2. C is 10, P, and 4, as the difference between D and C should be same as A and B. To find P, we can draw a line between A and C, and using the Pythagorean method, we can state that AC squared is equal to AD squared plus DC squared.
10 minus 5 square, plus P minus 2 square, plus 4 minus 1 square, equals AD square, which is 9 minus 5 square, plus P square, plus 1 square, and square of DC is equal to 10 minus 9 square, plus minus 2 square, plus 2 square. Yes.
And now we can simplify.
5 square is 25. P minus 2 square is P square minus 4P plus 4. And 3 square is 9. Equal to 4 square is 16 plus P square plus 1 plus 1 plus 4 plus 4. We can cancel out the P squares. So that gives us 38 minus 4P is equal to 26. This gives us
Minus 4P is equal to 12, and P is 3. For part C, we have already found the coordinates of C. We just have to change the value of 3 with P, so it makes us 10, 3, and 4. For part D, we should find the area of the rectangle ABCD. We already know the magnitudes of the sides AD and DC, so we can just multiply them.
1 square plus 2 square plus 2 square multiplied by 4 square plus 3 square plus 2 square. 9 plus
9 times 29 is equal to 261, which gives the area. In this question, it asks us to find PQ. So we can apply the cosine rule as we know 2 sides and 1 angle. So let's write the values. PQ square is equal to R square plus R square minus 2RR times cosine 2 theta. Now let's take the root.
2r square minus 2r square cosine 2 theta.
Since the question is asking us to find it in sinus form, we have to apply the double angle formula. So we can say that cosine 2 theta is equal to 1 minus 2 sinus squared theta. So let's rewrite it.
PQ is equal to square root of 2r square minus 2r square times 1 minus 2 sinus square theta.
Now we have to expand and simplify.
2r square minus 2r square plus 4r square sinus square theta. We can simplify these, and once we take the root of this equation, we get
PQ is equal to 2r sinus theta. Part B wants us to find the value of theta given this equation. We already know PQ, it is 2r sinus theta, so
1.3 2r sinus theta minus L, our length, which is equal to radius times angle. So we can say 2 theta r is equal to 0.
now we have to expand this,
2.6 r sin theta minus 2r theta.
and we have to factorize this.
So it gives us 2r times 1.3 sinus theta minus theta equals 0.
Since we know that in multiplications when the result is 0, one of the values should give us 0. And we know that radius cannot be 0, so we know that this value should be 0. So let's write
1.3 sinus theta minus theta is equal to 0.
We can put theta on the other side.
Which gives us 1.3 sinus theta is equal to theta.
To find theta, we should find the points in which these two equations intersect. We have to set mode to radian on my TI, and the window should have x minimum as 0 and x maximum as pi over 2, as x values cannot be larger than this. So let's draw the graphs. Now we have to calculate the intersect points. And as it can be seen, the x value is 1.22. So we can say that theta is 1.22 radian.
In part C, this function is given, and interval is 0 to pi over 2, and the question is asking us to sketch the graph. So let's sketch it. 2.6 sinus x minus 2x.
The second part of this question is asking us to find the root. To find the root, we have to find when y is 0.
So we have to go to calculate and press 0. For left bound, we have to enter at left, and for right bound, we have to enter at right and guess.
So x is 1.22.
Part D asks us to find theta, for which arc length is smaller than 1.3 pq.
We already know arc length and we already know pq, so let's write the values. So we can put them all at the same side. We know that r is positive, so this value should be positive as well. As you can see, this equation is the same one that part C asked us to sketch the graph of. So we have the graph right here. To have a positive value of theta, a positive value in the function, the values can only be between the root that we found, so it is 1.22, and 0. So these are the x values in which theta is more than 0.